Hi students, welcome to ACE Online. So in today's class we are going to discuss about some of the important questions which concerns to general science, that too physics and chemistry. So you already know the syllabus of CBT-1. So here if you consider general science, so almost you will get around 30 questions. So each question can carry 1 mark. So that's why here it is also one of the deciding factor to achieve your goal. Okay, so that's why guys you have to focus on 6th, 7th, 8th, 9th, 10th NCERT textbook related concepts, that to general science related concepts. Okay, so if you are properly follow the basics from 6th through 10th standard, then you will definitely get the good score, especially in this RRB JE examination point of view. So here I will provide some of the questions which is relevant to your examination point of view. So these are most expected questions, so that's why you should also focus on this, so you can definitely crack the examination. Okay, so I hope you can enjoy the questions what I am providing here. So here it is, the first question: light travel fastest through which of the following? So diamond, air, water, glass. So mostly guys in your examination point of view they are majorly focusing on applications of general science. For example, if you consider light, so in that actually light is having 10 phenomena, right? Rectilinear propagation, next one reflection, refraction, total internal reflection, interference, diffraction. Okay, so the polarization, number of concepts are there. So if you consider each and every phenomena of light, you have to focus on the applications only. Okay, so where would we use the phenomena of rectilinear propagation in our daily life? So these type of concepts are mostly expected in your examination point of view. So here it is, one of the application which concerns to light phenomena, light properties phenomena related derivative. So here it is, so light travel fastest through diamond, air, water and glass. So based on this shortcut you can easily get the answer. Actually if you consider refractive index, okay, it is almost okay, refractive index. So it can be represented with mu. Actually mu is equal to sin I by sin r, So this is also considered as Snell's law. Okay, so Snell's law. So here the concept is the velocity of light inversely proportional to mostly refractive index. It means if the refractive index value is high, then the velocity of light especially in that material should be low. So based on that, here first we have to know the refractive index of each and every constituent. So diamond, its refractive index value would be around 2.42. Air, so 1.005. next Water 1.3, okay, so 32 like that. Next glass 1.5. So it means light travel fastest means, so if the material is having lowest mu value, so which one is having lowest mu value here? So air. Okay, so air mu value would be very low, so that's why here the velocity of light would be very high. So that's why guys here the correct answer is option B. Option B is the right answer. So here also you can observe the concerned concept. So air, its refractive index would be around this one. Okay, so next water, next glass, next diamond. So here it is the velocity of light in those materials. Okay, it's next one. So glass around 1,97,000 approximately. Diamond. Okay, so but in air and vacuum it shows 3 into 10 power 8 meters per second. In air, at the same time in vacuum the velocity would be very high. Okay, velocity would be very high, so that's why here the correct answer is option B. So here it is, the next question. So match the following. So acid rain, aquaresia, next etching of glass, next king of chemicals, and on the side they mention NOCl, NO2, H2SO4, HF. So this is also very important. Yes, which is the correct option here? Yes, anyone? Okay. Acid rain, right? Acid rain, which is considered as the purest form of water, mostly rainwater. It means it does not having any impurities like carbon related, sulfur related, nitrogen related, oxides or corresponding acids, whatever it is. Mostly rainwater is considered as the purest one. Why? Because it does not having any impurities, but in the most of the regions, so it means if the human beings are surviving in those locations, the environment, okay, so the entire environment mostly be polluted. So in those locations, if you consider rainwater, it is officially treated like acid rain. Okay, so it means, guys, acid rain means it has some of the impurities along with water. So what are the major chemical constituents which are exist in acid rain? The first one is sulfur dioxide and the second one is nitrogen dioxide. Next, carbon dioxide also. Suppose if it is having these three types of chemical constituents, then its pH value, okay, acid rain pH value mostly considered like less than 5.6. So rainwater is act as an electrical insulator, but acid rain is considered as an electrical conductor. Why? Because it has some of the impurities. Next, when water reacts with sulfur dioxide in presence of excess amount of oxygen, then what will form? Then we can get sulfuric acid. Next, what about nitrogen dioxide? Nitrogen dioxide when reacts with excess amount of H2O, then it forms HNO3, nitric acid. Here also same thing, so H2CO3, carbonic acid. These are all considered as acids, na? According to Arrhenius acid base theory, these are all considered as acids. So it means it provides H plus ions. Okay, here each chemical can provide H plus ion. So next, H plus means these are considered as cations, na? So in the same manner here also we are getting anions. Okay, so anions, it means in this rainwater, okay, in this acid rain we have free ions. That's why it is treated like an electrical conductor. And which chemical is majorly responsible for acid rain? So first we have to give priority to sulfur dioxide followed by nitrogen dioxide. So that's why, guys, here the correct answer is, okay, next aquaresia, etching of glass. Next, king of chemicals. So king of chemicals means nothing but sulfuric acid. Okay, so sulfuric acid, king of chemicals. Why? Because this is the most widely produced chemical and the most widely used chemical. That's why sulfuric acid is pronounced as king of chemicals. Next one, etching of glass. Etching means to make a design on glasses equipments. So to make that one, we need some of the chemical. The majorly used one is hydrofluoric acid. So that's why, guys, here the correct option is mostly HF, hydrofluoric acid. Next, aquaresia. This aquaresia is also called as royal liquid. Okay, royal liquid means in this aquaresia gold can easily be dissolved in that. Okay, aquaresia is a mixture of nitric acid, HNO3 and HCl, hydrochloric acid. Here we should consider, we have to consider 1:3 ratio. So HNO3 1 ratio and HCl we have to consider around 3 parts of derivatives, na? So finally, guys, by mixing of these two chemicals we can get nitrosyl chloride, NOCl. Okay, NOCl. So that's why here this is the correct one. Next one, acid rain. So acid rain is majorly caused by, of course, SO2, and here they mention NO2, na? That's why based on the options we should consider like this. So QPSR, option B is the right answer. Option B is the right answer. So here it is, the next one. A common fluorescent tube contains sodium vapors, mercuric oxide and neon, and argon at low pressure, mercury vapors and argon gas. So which is the correct one here? Yes. Okay, right. So fluorescent bulbs. So in these bulbs we have mostly mercuric vapors. Okay, so mercuric vapors along with argon gas. So because of that, because of existence of these two chemicals, it shows or it produces mostly white light, na? White light. So here guys, option D is the right answer. Option D is the right answer. You can observe clearly here, right. So mostly in this fluorescent bulb we have mercuric vapors along with argon gas. Not only this one, if you consider tube light also, okay. So tube light, so same kind of chemical composition can be exist in that. Next we are also having street lights now. So we have street lights, right. So in those street lights it shows mostly two types of colors. One is white. So to exhibit white color it should have mercury and argon related derivatives, and the another one shows yellow orange color, right, yellow and orange color, mixing of yellow and orange color. To exhibit that it should be filled with mostly sodium vapors, okay, sodium vapors. So if you consider street lights, mostly it shows, some of the street light shows yellow along with the orange color, okay, orange color. To exhibit that it should have sodium vapors. Next if you considered white lights, okay, so white color lights mostly it has mercury along with argon related derivatives. Next here it is the next one, which is monobasic compound, H3PO4, H2O2, H3BO3, HF. First of all you have to know the meaning of monobasic. Monobasic means it indicates the intensity of, or the capability of, the capacity of an acid, okay. It indicates the strength of an acid, right. So here to indicate the strength of acid mostly we are using basicity, okay. So basicity, if basicity is high, the acidic nature of the chemical is also high, okay. The acidic nature, or it provides H plus ions very easily. If the basicity is high, mostly it's that chemical can provide H plus ions very easily compared with the remaining one. So that's why guys, that's why here we have to elaborate this concept. So H3PO3, so this is called as phosphoric acid. Cool drinks has some different taste, right. So mostly if you consider thumbs up or whatever it is, Coca-Cola products, so to exhibit that kind of pungent taste it should have mostly phosphoric acid related derivatives, okay. So this is the structure of phosphoric acid, and here it has 3 OH groups, okay. So 3 OH groups, it means if you observe oxygen, its electronegativity would be 3.5. Next, what about hydrogen? Only 2.1. It means here OH bond is considered like this. Here it is having 2 electrons. So these 2 electrons always moves towards oxygen only. Why? Because this is most electronegative when compared with hydrogen. Because of that, oxygen attains negative charge and hydrogen attains positive charge. So finally guys, from this OH what we get? H plus ion. Here also H plus ion. Here also H plus ion. It means totally 3 H plus ions we can get from this acid. So finally the basicity of this acid is 3. So how can we conclude that? Based on the H plus ions, okay. So the basicity means the number of H plus ions replaced by OH minus ions, or the number of H plus ions replaced by a base. Base means, suppose if you consider NaOH, this is base, right. Why? Because it has hydroxide ion, nothing but OH minus ion, okay. So here it releases H plus and bases releases mostly OH minus ion, okay. So finally what we get? H2O, okay. When acid mix with base, finally we can get water plus salt. So here to get that salt we need H plus ions, okay. We need H plus ions. Finally guys, the basicity of phosphoric acid is mostly 3. So how can we conclude that? Based on number of OH groups, or based on releasing capability of the concerned acid. So concerned acid. Next one, H2O2. So hydrogen peroxide. Actually its structure would be just like this. Here it has 2 OH groups. It means it releases 2 H plus ions. That's why its basicity would be 2. Next one, H3BO3. Okay, H3BO3. So this is called as boric acid. So BOH, and here also BOH, and here also BOH. So its structure would be considered just like this, okay. And here if you consider same kind of another molecule, so there is attraction between this hydrogen and this oxygen. This is called as hydrogen bonding. So because of that, okay, so because of that, yes, here one boric acid is having 3 OH groups, na? 1, this is 2 and this is 3, but 2 OH group ions are completely bounded with another molecule based on the hydrogen bonding. That is why here it releases only 1 H plus ion. Actually it has 3 OH groups, but because of hydrogen bonding it releases only 1 H plus ion. So based on that, here the basicity is considered like only 1. What about HF? It does not having any OH, even though it is considered like an acid. Why? Because HF is a strong acid, sorry, HF is looking like this, okay. Next, if you consider another hydrofluoric acid, okay, another hydrofluoric acid molecule, so fluorine electronegativity would be 4. Why? Because this is having highest electronegativity in the periodic table. So totally we have 118 elements in that. So which element is having highest electronegativity? Only fluorine. Its electronegativity would be 4. So because of that, this hydrogen is not freely released because of hydrogen bonding. Actually it shows 1, but that 1 is, it means it can provide 1 H plus ion, but it is not easy to get that H plus ion because of hydrogen bonding. Did you get my concept? So finally here the correct one is option C. Option C. So which one is monobasic? Only H3BO3. Of course HF is also up to some extent considerable one, okay. So but here in these two things we can get H plus ion easily from boric acid only. That is why option C is the correct answer. Next, chloroform. Chloroform in presence of sunlight. Chloroform in presence of sunlight, what we get? So first of all guys, we have to consider CHCl3. This is the formula of chloroform. So chloroform in presence of sunlight, what we get? Water gas, next producer gas, next phosgene, next carbon dioxide. So actually if you observed in movies, okay, so or some of the incidents which concerns to kidnap whatever it is, so we heard this chloroform related derivatives, na? So in our body the least particle is considered as cell, okay. Actually cell is having receptors like sodium, at the same time chlorine. If you consume chlorine related derivatives, cells can easily get into drowsiness, or cells can easily deactivated. Because of that we can get the drowsiness, okay. So drowsiness, it means the excess dosage of chloroform, it leads to unconsciousness, okay, unconsciousness. So this type of derivatives not kept under sunlight. Suppose if you kept under sunlight, what we get? It can be converted into one of the poisonous gas, okay, because of the existence of sunlight only. So it means like this. In presence of sunlight, so chloroform can be completely converted into, so COCl2. This is called as phosgene, okay. So phosgene, this is one of the war gas. It means in First World War these type of chemicals has been used, okay. So this is one of the chemical weapon. So finally guys, here the correct answer is phosgene. Its formula COCl2. So in First World War this gas was used. Next, producer gas means carbon monoxide plus nitrogen, okay. So this is called as producer gas. It is used as one of the fuel, okay. So just like CNG, next LPG, PNG, whatever it is, so this is also treated as one of the fuel in most of the aluminum related sectors, okay. It means nothing but it can be used in metallurgy to extract metals from concerned minerals, at the same time ores, next in glass industry, next in cement industry also, to get more than 1000 degrees centigrade. These type of chemicals are used as a fuels. Next one, water gas. This water gas is also called as syngas, okay. So syngas. syngas, its formula CO plus H2. This is nothing but water gas or blue gas or syngas. Blue gas or syngas. Last one, carbon dioxide, of course we already know that. Okay, right. So here the correct one is phosgene. So this is the most commonly used anesthetic agent. Okay, so not only this one, nitrous oxide. These two chemicals are used as the most commonly these two chemicals are used as commonly used as anesthetic drugs. Next one. So here it is the next question, with reference to noise pollution, what is the threshold limit for sensation of pain in the ear? Yes, good evening guys. Yes, good evening all of you. So what is the correct answer here? With reference to noise pollution. Yes, with reference to noise pollution, what is the threshold limit of sensation of pain in the ear? So noise pollution means if the intensity of sound, okay, intensity of sound is more than 80 decibels, then it is considered as noise pollution. Noise pollution. So which is the most noise polluted city based on the latest reports? Dhaka. Dhaka is considered as the most noise polluted city. Okay, right. So here they mentioned about threshold limit for sensation of pain in the ear. Suppose guys, if the intensity of sound is more than 120 decibels, means 120 to 130 decibels, so we cannot hear, or the ear cannot bear that kind of high intensity sounds, na? Okay, so that's why here the correct one is option 4. So 120 decibels, okay, 120 decibels, 120 to 130 decibels, actually this is the correct value, but based on the options we have to consider, mostly option 4 is the right correct one. Next, intensity of sound depends upon amplitude, okay, amplitude. Next, pitch. So pitch of the sound depends upon frequency. So frequency means number of waves per second. Next, intensity means, or amplitude means, the maximum displacement of a vibrating particle from a mean position. So this is mean position, okay, so this is the mean position. If you applied some force, mostly from this mean position it exhibit to and fro oscillation, na? To and fro means it up to some extent this particle, okay, so let's consider this is vibrating particle up to some extent, so this one reach to maximum altitude, na? So that one is treated as a amplitude, okay, so that one is treated as an amplitude. So finally guys, here the conclusion is the maximum displacement of a vibrating particle from its mean position is considered as amplitude. So mostly intensity depends upon amplitude, okay. Next, frequency, okay, so pitch depends upon frequency. You should also remember these 2 points, very important, especially in your RRB JE examination point of view. Not only RRB JE, if you consider any railway examination, so these concepts are very important. Okay, so more than 80 decibels, okay, if the intensity of sound is more than 80 decibels, so that is considered like noise pollution or sound pollution. So but our mostly our here, okay, our ear can bear only below 120. If the threshold limit is more than 120 to 130, mostly eardrum can easily get into destroy, na? So that is one of the disadvantage of high intensity of sound waves. Next, match the following chemicals with their applications. So sodium benzoate, saccharin, aspirin, baking soda. Here they mention antacid, analgesic, next food preservator, next artificial sweetness or sugars. Okay, right. So guys, we already know that we have number of artificial sweeteners. Okay, so saccharin, sucralose, aspartame, allotropes. Okay, aspartame. Next, allotropes, saccharin, so sucralose, almost these are all considered as some of the major examples of artificial sweeteners. So those chemical sweetness can be compared with sucrose only. Sucrose, nothing but table sugar. This is called as table sugar. You should also remember this one. So which chemical is considered as table sugar? Sucrose. Okay, so sucrose. Okay, right. So here it is the concept. So sodium benzoate. Sodium benzoate. This is the most commonly used food preservator. Food preservator. So that's why, guys, here the correct one is R for sodium benzoate. So this one is concerns to food preservator. Sodium benzoate or benzoic acid. This is the most widely used food preservator. If you consider chocolates, biscuits or any bakery food, so this is the most commonly observed food derivative. Na? And one more interesting point here it is, if you heat those type of chemicals, okay, actually it is exists in solid. At room temperature it exists in solid. If it is heated, then it can be directly converted into gas without formation of liquid. So this is called as sublimation. This phenomena is considered as sublimation. Sublimation. Okay, right. So next one, it means sodium benzoate can involve in sublimation process also. Next is saccharin. So this is one of the artificial sweetener. Its sweetness would be around 650 times when compared with sucrose. Okay, so to make sugar-free tablets, we are using these type of chemical derivatives, saccharin, sucralose, these type of derivatives mostly be used. Okay, right. So next one, guys. So that's why here the correct one is artificial sweetener. Okay, artificial sweetener. Next one, aspirin. Aspirin is the most widely used drug. Okay, so the most widely used drug is aspirin. So it is treated as analgesic to reduce body temperature, okay, to control the temperature of body. At the same time, if you are suffering with any body pain, generally this type of chemicals are most commonly be used. No? So that's why, guys, here the correct one is Q. Right. So the next one, baking soda. Baking soda, its formula is also very important. Sodium bicarbonate, NaHCO3. This is called as baking soda. Sodium bicarbonate. Sodium bicarbonate. Okay. So bi means baking soda. If we get bi, next here the pronunciation, you have to observe the phonetic sound of these two derivatives, baking soda. If you get bi, then it is treated like baking soda. Why? Because so same kind of another derivative is also there, that is Na2CO3. This is called as sodium carbonate. Sodium carbonate. Most of the students are confusing about these two terminology. Na? That's why simply you have to remember based on the phonetic sound. If you get bi, then it is considered like baking soda or edible soda. Okay, right. So here it is the formula. Next one. So this is washing soda. Okay, washing soda, and here the formula is Na2CO3. So finally here the correct one is so P. Okay, RSQP. RSQP. Option C is the right answer. Okay, right. So next one. So the hardest element is nitrogen, carbon, oxygen, fluorine. So here, if you are directly considered these elements, you cannot get the exact answer, right? That's why you have to consider in the form of allotropes. Then you can easily get the correct corresponding answer, right? So nitrogen. Okay, so nitrogen, next carbon, oxygen, fluorine. Actually, guys, if you consider carbon, it has some of the allotropes like diamond, right? So diamond, next graphite, next graphene, next C60, okay, C60, next carbon nanotubes. So number of allotropes it has. Here it is. These are all considered as carbon allotropes. Diamond, graphite, fullerene, carbon nanotubes, so graphene. These are all considered under the category of crystalline allotropes. Crystalline means the intermolecular distance between any two atoms would be very less, and it has it maintained in chronological order. But if you observe in amorphous, so it is amorphous means nothing but powder form. Here the particles are existed not a chronological order. It means it does not maintain the rigid shape. So the intermolecular distance would be very high, Okay, so particles are existed just like this. Okay, the zigzag orientation of arrangement, particle arrangement we can observe in this amorphous allotropic forms. Na? So finally guys, if you consider carbon, it has some of the hardest derivative forms like diamond, graphene, C60, CNT. As of now we have number of chemical compounds. Among them, which is considered as the hardest one? Not diamond. The correct one is graphene. This is the hardest one. So far we have number of chemical constituents, right? Among them the hardest one is graphene. So that's why guys, here the correct answer is option B. Why? Because graphene formula is nothing but C, nothing but carbon. Because of that, carbon is considered as the hardest element. Hardest element. Okay, right. So next one. Okay, so next one, which of the following is most viscous? Most viscous. Actually viscous, if you observe fluids, fluids means liquids at the same time gases. These two are not having a rigid shape. Okay, next it always flows from high temperature region to low temperature region, high pressure region to low pressure region, low pressure region. So here if you consider liquids, it shows some of the properties, okay, some of the characteristics like cohesive forces, adhesive forces. Based on that, it exhibit surface tension phenomena. So contact angle, okay, angle of contact. Next one capillarity, next one viscosity. Okay, so viscosity. Viscosity means it is the property of liquid. It means the resistance of flowness of liquids is nothing but viscosity. Okay, so finally guys, we can easily elaborate this concept by using some examples. If you consider honey, okay, honey, at the same time water. Okay, so when we pour water on any surface, mostly it can easily flows just like this, na. But what about honey? It does not easily move towards forward direction. Why? Because in honey it has a layer type of arrangement. Between any two layers of this chemical, it has strong attractive forces. Because of that, here some force resist the flowness, okay, flowness of the liquid. Actually these layer, okay, so let's consider this is first layer. This first layer molecules are always try to move towards forward, but this second layer particles are drag these particles towards backward. So because of that, if the viscosity would be high, mostly that chemicals not be considered, if the viscosity would be high, mostly those chemicals cannot easily flow from one point to another point. Okay, so finally which one is most viscous? Honey. Okay, honey is having highest viscosity, na? So compared with water, gasoline, at the same time alcohol. Here it is the definition. Viscosity is a measure of fluid resistance to flow, compared with any remaining chemicals, mostly honey at the same time grease. These two chemicals are not easily flow from one point to another point because of high viscosity. Okay, right. So next, what are the units of viscosity? You should also remember this terminology. So Pascal second. So Pascal second or kilogram per meter per second. Kilogram meter per second. So these are the units of, these are the SI units. Next, the most commonly used units are poise. Okay, so these are CGS units. So CGS units, so nothing but centipoise. Okay, we have mostly we are using centipoise. 1 centipoise is equal to 0.01 poise. 0.1 poise. Okay, you should remember these two terminology also. Next one, due to its very low solubility in blood, which one of the following is mixed with 20% oxygen and supplied to deep sea divers? Actually guys, if you observe deep sea divers, okay, so this is considered like deep sea diving. So in that they are using some kind of oxygen carrying cylinders. Okay, for artificial respiration they are carrying some cylinders, na. This is called as scuba tank. So in this scuba tank, what kind of chemical composition is there? The most commonly used one is nitrogen along with oxygen. This is called as EAN, enriched air nitrox. This is the most commonly used one. Okay, it means suppose if the level of the water, okay, if the depth of the water level would be very low, okay, if the depth is very less, then we have to use EAN, enriched air nitrox. Suppose if the depth mostly be high, depth of the water level would be very high, then instead of this nitrogen we have to mix with helium, okay, helium along with the oxygen. Generally we have to consider the nitrogen, and this is the commonly used one. If the depth is very low, then we have to consider nitrogen along with oxygen, but if the depth is very high, instead of nitrogen we have to consider helium. The reason is at this level mostly pressure would be very high, okay. If pressure increases, nitrogen can easily dissolve in the blood. That's why with hemoglobin nitrogen can form a stable complex. So because of that, the concerned person can easily die. So to overcome these type of complicated issues, we have to consider helium related derivatives now. Why? Because helium does not easily dissolve into the blood. That is the major advantage, okay. So that's why guys, here the correct answer is option B, helium. Helium is the right answer. Okay, right, so next one, mirage is the best example for which of the following phenomena? Reflection, next refraction, total internal reflection, next scattering of light. So mirage means when a light, okay, let's consider here it is a rarer medium, okay, rarer medium, and here it is a denser medium. When light travel from rarer to denser, then what will happen? Mostly we get refraction. But if we consider light from denser to rarer, mostly almost all these rays are bounce back in the denser medium only. Did you get my point? When a light travel from denser to rarer, okay, almost all the rays, if the angle, okay, that is considered like incident angle. If the incident angle is greater than critical angle, then almost all the rays are reflected in the same medium. Okay, so same medium instead of enter into the rarer. So this phenomenon is considered as nothing but total internal reflection. So mostly in summer, roads are appeared like wet because of total internal reflection. It means guys, here it is an observer, okay. So near to observer mostly there is a cold air, and here it has some hot air. Hot air means number of particles would be very less, cold air means number of particles would be very high. So this is denser medium, okay. So this is denser. What about here? This is rarer, okay. When light travel from denser to rarer, then what will happen? Mostly it shows total internal reflection. So here it shows some wet type of conditions. Now there is no that kind of situation, but in summer mostly we can observe this type of phenomena because of total internal reflection. Option C. Option C is the right answer, okay. So here it is the meaning of total internal reflection. Yes. So here when light is passed through denser to rarer, here the critical angle of this material is 48.8 degrees. Na? So more than 48.8, almost all the rays are bounce back into the same medium. What about below 48? It means if the incident angle is below 48, then what will happen? So it entered into the rarer medium. Suppose if it is higher than the critical angle, then the rays do not enter in the rarer medium. It almost bounce back into the same medium, okay. Right. So here it is the next one. Here they majorly raised about alloys, at the same time some of the ores. Okay, right. So nichrome. Nichrome means nickel, chromium, next manganese, okay. Nickel, next chromium, next manganese, next iron. This is considered as nichrome. it has high resistance, okay, high resistance. Mostly by using these type of derivatives we can make electric stove, water heaters, boilers like that. So that's why here it is the correct one. Next, stainless steel. Stainless steel means it has iron, next nickel, next chromium. These type of chemical, these type of metallic composition mostly observed in stainless steel. By using stainless steel, present we are making our Indian rupee coins, Indian rupee coins. So that's why guys, so present Indian rupee coins does not exhibit any rusting phenomena because it has excess amount of nickel, at the same time chromium. So these two metals does not support any rusting phenomena. Yes, next one horn silver. Horn silver means nothing but AgCl, okay, so silver chloride. So this is the main ore of silver, main ore of silver. Next, galena. Galena means nothing but lead sulfide. So this is the main ore of lead, okay, main ore of lead. Here it is, so lead sulfide, lead sulfide. So finally guys, so nichrome. Next, stainless steel, okay, so stainless steel, the correct one is Indian rupee coins. Next, horn silver, so Q. Next, galena, so T, it means RuQt, option C is the right one, okay. Next, what is the source of electric energy in the artificial satellites? Option A, mini nuclear reactors, next solar cells, next a dynamo, next a thermocouple. Okay, mini nuclear reactor. So present guys, according to IAEA, International Atomic Energy Agency, based on the capacity of the nuclear reactor, it has been classified into nuclear reactors, mostly be classified into three types. So small modular nuclear reactor, next medium molecular nuclear reactors, next large nuclear reactors, okay. So here mini nuclear reactors means its capacity would be less than 25 megawatts. If the capacity of the reactor is less than 25 megawatts, mostly those are considered under this category. Of course, in initial days we are not using, not only initial days, even nowadays also we are not using nuclear reactors, especially in artificial satellites, okay. So that's why option 1 is wrong. Next, solar cells, nothing but solar panels. So mostly we are using solar panels only, okay. These solar panels are made up with NPN diodes, NPN diodes. Next, dynamo. So in dynamo what we have, magnets, these type of magnets, at the same time copper coil is there, na? So in that mostly mechanical energy can be converted into electrical energy, of course you already know that. Next, the thermocouple. Thermocouple is a mixing of two metals like copper, at the same time iron. By using these derivatives we can get heat and hot and cold junction also. So especially this type of phenomena you can observe in Seebeck effect, okay. So Seebeck effect, at the same time Fetelier, so Fetelier effect also. So finally guys, here the correct one is mostly in solar panels, sorry, mostly in artificial satellite. So what kind of derivatives are mostly be used? Solar panels, okay. So solar panels, so when sunlight incident on it, so here light energy can be converted into electrical energy, that too here we get a DC current, okay. So to convert DC into AC, what we used? Inverter, okay. So we used inverter. So that's why here the correct one is option B. Option B is the correct one. Okay, right. So next one, the law of triad is applicable of a group of, law of triad. Actually this concept was proposed by Dober-Einer, okay. So Dober-Einer, according to Dober-Einer, or according to law of triad. Actually triad means it is a group of elements, it has three elements, okay. So the mass of second element is equal to arithmetic sum of first and third element, arithmetic mean of first and third element. Let us consider one example. Suppose if you observe lithium, next sodium, next potassium, actually lithium mass would be 6.9, approximately 7. So next potassium 39. So what about sodium? 23. Suppose if you consider first and third element, okay, so arithmetic mean of first and third element, so 7 plus 39 by 2, what we get? Mostly 23, isn't it? 23. It means it is approximately equal to the second element, second element. So this is the meaning of law of triad, which it was proposed by Dobereiner only. Okay, so here we have some of the Dobereiner triads. One is lithium, sodium, potassium, but here instead of lithium they mentioned rubidium, so that's why it is wrong. Next carbon, nitrogen, oxygen, this is also wrong. Next chlorine, bromine, iodine, yes, this is the correct one. Next so option C is the correct one only. Okay, so here guys you have to remember lithium, sodium, potassium, this is one of the triad. Next calcium, strontium, barium, this is also second triad, okay. Next next one, so chlorine, bromine, iodine, this is also the next triad. Okay, next sulfur, tellurium, tellurium. Next iron, cobalt, nickel, approximately these 5 are considered as Dobereiner triads. Okay, you should remember almost all these things. Alright, so next one, the optical instrument that is used by army personnel to see their enemies while hiding themselves is. Okay, so which optical instrument mostly be used by armed persons to observe the enemies? Okay, so from hiding from any location. So here they mentioned stethoscope, next periscope, next simple microscope, next compound microscope. Here it is. This is considered like, this one is treated as periscope, na? So these type of instrumentation we can observe even in submarines also. Okay, so it works on the phenomena of reflection. It's looking like this. Here it is having two plane mirrors. Those plane mirrors angle would be 45 degrees. Okay, 45 degrees. When you place an object here, we can easily observe from this location. So that's why guys, this type of instrumentation is majorly used by armed forces. Okay, here the correct one is periscope, option B. Okay, right. So the next one, the element used to make controlling rods in nuclear reactors. Okay, so if you observe a nuclear reactor, actually its arrangement would be just like this. It has, mostly it has fuel rods. These fuel rods are made up with either uranium or plutonium. So present in India we are not having thorium based reactors. Recently a prototype thorium based reactors were recently launched by BARC, Baba Atomic Research Center. It is a prototype reactor, that too it was launched in the region of Vizag. Suppose if it is succeeded, mostly in future we will get the bulk number of thorium based reactors also. Of course India is having largest thorium reserves. Okay, so but we are not having a complete type of a complete version of a nuclear reactor which concerns to thorium. So present we are under development stage, we are making some kind of nuclear reactors which is relevant to thorium. So if it is succeed, then in future we will expect this type of reactors also. Okay, so that's why present we are having only uranium and plutonium. Next, when a neutron bombardment with these fuel rods, okay, actually in these fuel rods we have a numerous number of atoms. Okay, let's consider one uranium atom. When it is bombardment with one neutron, what we get? So 3 neutrons, na? Again each neutron can collapse with, okay, can target another uranium atom. Next you can get so multiple number of neutrons. So this reaction will be continued until the uranium, okay, until the fuel rod completely converted into energy. Okay, so mostly in some situations we have to control the speed of neutrons. Okay, if it is not possible, then it is treated as an atomic bomb. Mostly in atomic bomb we cannot control this type of nuclear fission reactions. This is called as fission type of reaction, but in nuclear reactors we have concerned arrangement to control the speed of neutrons. Okay, so what we have, mostly moderator, at the same time controlling rods. So what is the importance of controlling rods? It reduces the speed of, okay, it slow down the speed of neutrons, especially in nuclear reactors. Those are mostly made up with either boron, at the same time cadmium. So why should we consider only these two elements? Because these are the good adsorbers with respect to fast neutrons. It means, guys, let us consider this is a boron rod. So when we get a fast neutron, so in presence of boron, mostly these neutrons are completely adsorbed. It means completely fixed on the surface of the boron, at the same time cadmium. That is why these are the most widely used derivatives to make controlling rods. So here the correct one is 1, boron, at the same time cadmium, 1 and 3. 1 and 3, option B is the right answer. Okay, right. Next, electromagnetic radiation used in, what kind of electromagnetic radiation used in radar? X-rays, microwaves, alpha rays, next gamma rays. Actually, guys, radar stands for radio detection and ranging. Okay, so radio detection and ranging system. This is considered as radar. Okay, actually in this radar we are using mostly radio waves, at the same time micro. Okay, so microwaves also here they mention option B. So microwaves, option B is the correct answer. Right. Next one. So match the following. Here, guys, they mention oxide, peroxides, next superoxide, suboxide. This is a basic question. So based on the nature of the number of electrons in the oxide, we can differentiate whether it is peroxide or superoxide. Okay, yes. So oxide means its formula should be just like this. So O minus 2. Peroxide means O minus 1 or O2 minus 2. If it is having this type of arrangement or this type of ions, then it is treated as peroxide. Next, superoxide means O2 minus. This is called as superoxide. Next, suboxide means it means it has less number of oxides when compared with the required one. Okay. So finally here the correct one is oxide. Yes, so here it is Na2O. So based on crisscross method, if you consider sodium oxide, okay, what we have here, the suffix number is 2, here it is 1. So based on crisscross method we should consider like this. So this one goes here and this one moves here. So finally Na1 and O2. So this is the metal, that is why it attains positive charge. This is a non-metal, due to that it attains negative charge. Okay. So here it is having minus 2. If it is having minus 2, O minus 2, then it is treated as oxide. Next, what about peroxide? Peroxide means it has either O minus 1 or O minus 2, O2 minus 2. Suppose if you observe this compound Na2O2, so here also the same thing. So based on the crisscross method, okay, so Na and O2 minus 2. Actually, guys, this is treated as a one of the ion, not considered like it is an oxide. So because of that, here we can get O2 minus 2, and here it is Na plus 1. So this is peroxide. Next one, superoxide. So here it is. Actually potassium, how many oxygens we have? How many potassiums we have? 1. How many oxygens we have? 2. Okay. For 2 oxygens, 1 potassium is there. Based on the crisscross method, if it is moves here, then what we get? O minus 1, O2 minus 1. If it is having O2 minus 1, what we call? So superoxide. Next, suboxide. Actually 3 carbons are there, na? For 3 carbons it has only 2 oxygens. but here it needs more than 2 oxygens, it means 3 or 4 oxygen atoms mostly be needed, but here it has inadequate amount of oxygen derivatives, because of that it is treated as a suboxide. So finally PQRS, option A is the right answer. Okay. So this is the standard, this is the level of standard mostly we expect in RRB JE point of view. Next, which statement is correct? Statement 1, silver and copper are good conductors of electricity. Statement 2, rubber and glass are insulators of electricity. Yes, so silver and copper are good conductors of electricity. Of course, option 1 is the correct one. Okay, so silver, so this is the best conductor, best electrical conductor, and copper is also considered as one of the conductor. Now why? Because its conductivity would be very high. Okay, its conductivity would be very high. Next one, so statement 2, rubber and glass are insulators of electricity. So in copper and silver, okay, if you consider copper and silver, it has free electrons. Okay, so free electrons, because of that these two are treated as a good conductors with respect to electricity, at the same time thermal conductivity also. Okay. Next, what about rubber? It does not having any free electrons or ions. In the same manner, glass is also not exhibiting any free ions or electrons. Na? So due to that it is treated as an insulator with respect to electricity. Okay. So finally guys, these two statements are exactly correct one. Of course, here if you observe diamond, okay, so diamond, it has highest thermal conductivity, as of now we have number of materials, right. So among them which one is having highest thermal conductivity? Only diamonds, because its conductivity, thermal conductivity value would be around 2000 to 2200 watts per meter per Kelvin. So silver thermal conductivity, not electrical conductivity, here I mentioned only thermal conductivity values, so 429 watts per meter per Kelvin. So copper, gold. Okay, so these are some of the examples of those derivatives. Next, select the correct one, correct statement from the following one. So carbon, okay, so what we call king of chemicals? Wrong. Actually carbon is treated as king of elements. Okay, king of elements. Why? Because carbon can form around 1 crore compounds. So this type of tendency not exhibited by any other element, especially in the periodic table. That's why carbon is treated as king of element. Okay, king of elements, not chemicals. Next, sulfuric acid, king of elements. Actually sulfuric acid is treated as king of chemicals, not elements. Why? Because this is the most widely used and most widely produced chemical. So that's why it is treated as king of chemicals only. Next, Rm, king of solutions. Actually guys, Rm is treated as king of metals. Okay, king of metals, nothing but gold. Rm means the Latin name of gold is treated as Rm, na? So so it is also treated like king of metals. Next one, zinc oxide, philosopher's wool. Of course option D is the correct one. Zinc oxide, actually it is in nano size, it is mostly be used in sunscreen lotions to protect from ultraviolet rays. When ultraviolet rays are incident on zinc sulfide related derivatives, within fraction of seconds almost all the rays are getting to be bounced back. That is the specialty of zinc oxide. That's why these derivatives are especially used in the sunscreen lotions. Okay, so here the correct one is option C only. Sorry, option C. It means D. This one, zinc oxide. It is also called as philosopher wool. Zinc oxide. You have to remember the name of philosopher wool, the chemical name of philosopher wool. Next, the principle involved in the motion of rocket. Actually guys, if you consider rockets at the same time missiles, okay, it follows Newton's third law, na? Newton's third law. For every action there is equal and opposite reaction. Okay, here action and reaction both are same, both are having same energy, same kind of forces, but one is towards but both are in different directions, that is the only difference here. So if you consider missiles, it follows Newton's third law. From this Newton's third law we derived law of conservation of momentum, okay, this one, law of conservation of momentum. So this is also derived from Newton's third law. So that's why guys, if they mention the motion of rockets, you have to consider law of conservation of momentum only, okay. So it means momentum is mass into velocity. Let us consider two objects. So these are the two moving objects, this is the direction of those two bodies. Here it is having m1 mass and here it is having m2 mass, and velocity would be v1 and velocity would be v2. So m1 into v1 what we get? So p1, nothing but momentum. Next here also p2. So before collision, actually these two are in this same direction, na? So that's why these two are in opposite direction. Opposite means nothing but Newton's third law. When the two objects are bombarded with each other, then what will happen? So before the collision, the momentum would be considered like p. So after the collision, the momentum would be considered like p1 plus p2. It means before collision the momentum is equal to after collision, okay. There is no changes or there is no variation of momentum, na? This is considered like conservation. This is nothing but law of conservation of momentum. Actually it is derived from Newton's third law. So that's why guys, here the correct option is option B only, okay, option B only, right. So select the following molecules, compounds having same atomicity. Atomicity means the number of atoms in a molecule, or compound, whatever it is, okay. If you consider carbon dioxide, how many carbons we have? 1. How many oxygens we have? 2 oxygens, okay. So the number of atoms are 2, na? Number of carbon atoms are 1, na? So 1 plus 2 what we get? 3. What about here? So 3 plus 1 plus 3, 3 hydrogens, 1 boron, 3 oxygens, so 7. Next what about here? 3 borons, 3 nitrogens, next 6 oxygens, so 12. Next C6H6, so 6 carbons, next 6 hydrogens, 12. Next N2O. N2O means mostly here 2 nitrogens and 1 oxygen. Here A and E, these two are having same atomicity. Next C and D, these two are also having same atomicity. But here based on the options we have to consider only C, okay. Option C is the correct one. Next, the purpose of using electric fuse in the electric circuit is, actually guys, in domestic purpose okay, mostly in houses also we are using electric fuse, right. So what is the advantage? If you are getting high voltage of current, high voltage current, mostly it can collapse or it can destroy the most of the electronic gadgets, na? So to overcome this type of phenomena we are using electrical fuse wire. If you are getting high voltage of current, mostly that fuse wire getting to be melted, and the power supply within a small span of time, the power supply can automatically controlled, right, or the power supply can almost stop. So that's why we are using electrical fuse wire, okay. So to protect from electrical circuit from excess electrical current, we are using electrical fuse wire. Actually an ideal fuse wire is made up with, fuse wire can be made up with solder. This is one of the alloy. Solder means lead plus tin derivative. So why should we use only the solder material as an ideal to make an ideal fuse wire? The reason is it has high resistance and low melting point. So if you are getting high voltage, then that electrical energy can be converted into heat energy. This phenomenon is called as resistance, okay. If you are getting high amount of heat, then the wire easily getting to be melted, na? So that's why we should use lead plus tin derivatives to make ideal fuse wire. It has high resistance, at the same time low melting point. So this is fuse wire, okay, you already know that. Next, the oxidation state of chlorine in bleaching powder. Actually guys, bleaching powder formula CaOCl2, this is called as calcium oxychloride, calcium oxychloride, calcium oxychloride. If you are directly solve the oxidation state of chlorine, mostly you can get just like this, okay, calcium, it concerns to second group, that's why you have to choose +2, oxygen. Oxygen state would be -2. Next, 2 chlorine atoms we have, na? So the total value is equal to 0. Why? Because it does not having any number on this molecule, okay. So totally, so chlorine is equal to 0. It means here if you are directly considered the oxidation state of calcium and oxygen, we can get the chlorine oxidation state would be 0. But here of course option D is also there, but this is absolutely wrong, okay. Actually chlorine is connected to calcium in this manner. If you know the structure of if you know the structure of bleaching powder, then only you can get the exact oxidation state of chlorine atoms, otherwise it is not easy, okay. So actually guys, oxygen, calcium oxygen state is +2, everyone knows about it. Why? Because it is a metal and the two it concerns to second group, okay. If any metal or if any element concerns to second group, it definitely shows +2 configuration, or +2 oxygen state, okay. Next, oxygen oxygen state would be -2, there is no change. So what about chlorine? Here one chlorine exhibit -1 oxygen state and another chlorine exhibit +1 oxygen state, okay. Why? Because here compared with the chlorine, oxygen electronegativity would be very high. Because of that, here it attains -2. Actually chlorine oxygen state is -1, but here we should consider +1, because so beside this chlorine we have high electronegativity element, that's why it attains positive charge only. So this is one of the exception. So finally here chlorine attains +1 and -1, okay. Option C is the correct answer. Next, an impossible set of 4 quantum numbers of an electron is. Guys, you have to remember this shortcut. Based on that you can easily get the correct answer. So L value, okay, these are all L values. L values is always less than M value, okay, always less than M value. It means you have to consider only numbers, not sign, okay. If it is like this, mostly this type of configuration is not existed. Did you get my point? Let us see the first one. So n is equal to 4, this is the principal quantum number. L value means S, P, D, F, these are the orbitals, na? So what is the L value of S orbital? 0. What about P? 1. What about D? So 2. What about F? 3, okay. So it means here they mention 2, right? L is equal to 2. So L is equal to 2 means 4d orbital, okay. So d orbital M values are so 0, -1, -2, +1, +2. Next, p orbital M values are 0, -1, +1. Next, s orbital M values are 0 only, okay. So here without using this concept you can directly solve that one. So first of all, here L value, M value both are same, so that's why this configuration mostly existed. Next, L and M value, this is also same, mostly existed. L value, M value, only you have to consider values, not the sign. Here M value is higher than the L value, that's why this configuration is not existed. Next, this one, both are same, so that's why this one is also existed. Suppose if you apply this concept, what we get? So 4d, and here M value is -2, na? -2, in that one electron is there, it means 4d1. Next, so n is equal to 4, this is principal quantum number. L value is equal to 0, means they mentioned s orbital. Next, M value is equal to 0, so M value is equal to 0 means this orbit, right? this orbit, and here they mention +1. +1 means it has 1 electron. If they mention -1, it has 2 electrons. That is the meaning. Next, n is equal to 3, right? Next, L is equal to 2, so 3d. Okay, next m is equal to -3. If you are getting d orbital here, the magnetic quantum numbers are mostly existed in between -2 to +2, but they mention -3. That's why this configuration is not existed. So without having this knowledge, you can easily solve that one by remembering of these derivatives. Okay, right. So here the correct one is option C. Next, the law of multiple proportions was observed for the pair. Law of multiple proportion actually proposed by John Dalton. Okay, so John Dalton here, so John Dalton, according to law of multiple proportions, okay, so if you consider a fixed element, when it is reacts with another element, okay, nitrogen, and reacts with oxygen, then we can get N2O, next N2O2, next N2O3, next N2O4. Okay, it means here the mass of one element is same, but then another element mass should follow the simple proportions. Okay, mostly it follows simple proportion. So this is nothing but law of multiple proportions. Actually it was proposed by John Dalton, you have to remember that. So this concept mostly be exhibited by oxides of nitrogen, oxides of carbon also. Here how to remember, how to recognize the concerned derivatives, you have to remember one thing, in those two derivatives same kind of oxides, whether it is nitrogen or carbon or copper or iron, whatever it is, mostly it has same kind of oxide related derivatives or sulfur related derivatives. So one metal mass would be should be same. Next, remaining metal or remaining element, metal or element, whatever it is, okay, so remaining element should follow the simple proportions, then only it is treated under the category of law of multiple proportions. These are all basics, guys. So that's why here the correct option is option B. In your examination point of view, you have to remember, so who one proposed law of multiple proportions? John Dalton. The nature of smelling salt. Smelling salt formula, ammonium chloride. Okay, this is ammonium chloride. Actually you have to divide these chemical derivatives into concerned ions like NH4 plus, this is cation, and Cl minus. Okay, so how to get this Cl minus, from which acid mostly we can get the chloride ions? Hydrochloric acid, HCl. Okay, so from this we can get the chloride ions. This is strong acid. What about NH4 plus? Mostly ammonium hydroxide, or you can also consider just like this, you have to add hydroxide ion to the cation and H plus ions to the anion. Finally we can get these type of chemicals. This is weak base, and this is strong acid. Here one is weak and another one is strong. So finally what we get, when acid reacts with base, we can get the salt. Okay, we can get the salt, and the nature of the salt always attain the acidic nature. Why? Because here this is the stronger one. Suppose if we are getting stronger base, then we can get the nature of the salt would be basic only. Okay, so finally here the correct one is acidic. Option A is the correct one. So this is smelling salt. Mostly in narcotic analysis also these type of derivatives are being used. Next, optical fibers are used in communication or developed based on the phenomena of. So optical fibers, okay, in optical fibers you can observe glass related material, okay, glass. So when a light instant or when a light is passed through these type of materials, nothing but denser materials, this is denser, right, denser material, almost all the rays are reflected in the same medium, okay, same medium. This is considered like TIR, total internal reflection. It means in this material the velocity of the light would be around 2.4 into 10 power 8 meter per second. Actually the velocity of light in vacuum or the velocity of light in air approximately 3 into 10 power 8, but in this type of optical fibers its velocity approximately reduces around 60,000 meters. Okay, so 60,000 kilometers per second. Okay, 60,000 kilometers per second the velocity mostly be reduced by the propagating of the light through this material. Okay, here the correct option is option B only. So optical fibers. And who is considered as the father of optical fibers? Of course an Indian. His name is Narendra Singh Kapani. Next, noble gas without p electrons. Okay, so actually guys we have helium, neon, argon, krypton, xenon, radon, next oxygen. So helium, its configuration 1s2, neon, so 2s2 2p6, next argon 3s2 3p6. It means the general configuration of the noble gases are considered as ns2 np6. Here 4s2 4p6, 5s2 5p6, 6s2 6p6, 7s2 7p6, but this element does not having any p electrons. That is why here the correct one is option C. Okay, helium. Okay guys, so this is about today's class. So we covered almost number of concepts. So in coming sections also we have to plan some of the major related derivatives which is important especially in RRB JE point of view. I hope you understood the present explaining concepts. Okay, so we will meet in the next class, right? Thank you, have a nice day.